The manipulator is not a simple serial manipulator like those studied in the course. This connection results in non-independent motion of the manipulator, so when the shoulder joint rotates, the elbow rotates as well. This is due to the location of the elbow servo, which is not at the elbow joint, but instead at the base. The base rotates directly via a single servo, the shoulder rotates with a direct connection to a servo as well, and the elbow rotates through a linkage connected to a separate servo motor. The gripper opens and closes via a simple linkage and two spur gears connected to the gripper, and when rotated, both grippers open or close accordingly. The manipulator is controlled via analog inputs on a joystick connected via USB. This signal is sent through the USB TTY USB 0 hub to ROS, which interprets it via the Talker Python code. The Talker.py also imposes the unique angle restrictions on each of the servos. If the joystick input for a servo exceeds its boundary, the angle sent will be the boundary angle, and an error message will be printed on the terminal. This is then sent to the Arduino and is interpreted by the rawsub.ino, where the signal is provided to the servo motors as manipulator motion. The major issue we had with the manipulator was before calibration. If the servos attempted to rotate beyond their own bounds, the manipulator would move erratically and crash the raw serial node in the terminal. This issue was almost entirely mitigated by physical servo calibration and appropriate bounds in the Talker.py. Upon receipt of the manipulator, the servo motors were not calibrated. When the code initialized the servos to 100 degrees, the links physically didn't point to 100 degrees. By disassembling the robot, the servos could be calibrated manually. We ran a code that would lock each servo in the 90-degree position. Then, we reassembled the linkage in such a way that each of the links were at roughly 90-degree angles. That way, angle signals that are sent from the Talker and Arduino code correspond directly to the angle of the manipulator links in physical space. The linearity of the servos were also checked, and there was no issue. The Python code outputs now reflect the servo outputs one-to-one. The requirements for this project were provided in the form of angle restrictions for the 4 joints of the manipulator. These restrictions are 60 to 140 degrees for the base, 70 to 120 degrees for the shoulder, 70 to 130 degrees for the elbow, and though there was no provided restriction for the gripper, we have imposed our own restriction of 90 to 150 degrees. Here we see the base of the manipulator, rotating between its angle restrictions of 60 to 140 degrees. Here we see the shoulder joint of the manipulator, rotating between its restrictions of 70 to 120 degrees. Here we see the elbow rotating between its angle restrictions of 60 and 130 degrees. We did experience difficulty with the elbow angles. Because of interference of the linkage, the servo is physically incapable of reaching the provided bound, 70 degrees. It can usually reach an absolute minimum of 80 degrees, depending on the shoulder angle. Here we can see the gripper rotating between our set restrictions of 90 to 150 degrees, resulting in a fully open and nearly closed configuration for the claw. When opening and closing the gripper, due to the machining and the shape of the spur gears, the gripper will occasionally get stuck in the fully open or fully closed position, as evidenced in this video. This is likely caused by both the play and gear teeth and the screws attaching the manipulator claw to the head of the manipulator. Fun! Just put that in at the end. Honestly, it was fun making the video. Oh man, look at that manipulator go. Look at that arm rotate. Psh, psh, woo.